So we're going to work with lots of different inequalities in this one, in this section 1.8. So let me start with problem number 16. 3x plus 11 is less than 5. Now, solving this is only part of what I want you to get out of problem number 16. So solving it, we would subtract 11. 3x is less than negative 6. Divide by 3, x is less than negative 2. There's two other things I want you to get. This is the inequality. Well, that's great for the inequality, but sometimes I'm going to ask you to graph it. So graphing it, I'm going to put a dot on number 2, or negative 2. And because I'm not actually including negative 2 itself, I'm going to draw a hollow circle around that, an empty dot. Now, which way am I going to find numbers that are less than negative 2? To the left or to the right? To the left. Good. So I'll draw an arrow to the left. So I got the inequality here, and then this is, of course, is the graph. And there's one last thing that I want you to be comfortable with, and that would be the interval notation. So interval notation. Interval notation runs from the left-hand endpoint to the right-hand endpoint. So from left to right. So let's take a look at our graph here and try and imagine some things that Ramanujan would imagine, which is things at infinity. So to the very left-hand end of this would be negative infinity. So that's the left-hand endpoint of our interval. The right-hand endpoint is negative 2. And because we're not including negative 2 itself, I'll use a parenthesis. If I wanted to include that point, then I'd use a bracket. And we'll see a nice contrasting example with problem number 18 coming up in a second. But that's it. There's three things that I want you to know the equivalence between: the inequality, the graph, and the interval notation. So we have all three of those for problem 16. Side by side to that, let me do problem number 18. And 18 has a couple of important little twists and differences. It's 5 minus 3x is less than or equal to, is that negative 16? Yes. Okay, thank you. Negative 16. So first things first, I'll subtract 5 from both sides. You get negative 3x is less than or equal to negative 21. And here's one of the things that you have to be careful about. To finish solving here, what am I going to divide by? Good. When I divide by a negative or multiply by a negative, the sign flips. So that's going to be x is greater than or equal to 7. So there again, there's your inequality. As far as the graph is concerned, I'm kind of a minimalist. I draw the least amount that I have to. All I need is a number line and the number 7. Now, am I including 7 as part of my answer key or my solution here? Yes. So this time I'm going to use a solid dot. Which way is the arrow going to run? To the right or to the left? To the right. I want numbers that are bigger than 7. Bigger numbers are to the right. So the last but not least, the interval notation. The left-hand endpoint is 7. The right-hand endpoint? Positive infinity. Thank you. Now infinity and negative infinity get parentheses. But here with 7, I'm going to use a bracket to indicate that we want to include the 7. Now some people, instead of the solid dot and the hollow dot on their graphs, use brackets and parentheses. I'm fine with that. If you're comfortable with that, that's fine. I'm not going to be really dictatorial about which way you write it. But you should be able to go back and forth between the inequality, the graph, and the interval notation. It's unlikely that I would ask for all three of them in one particular problem, but you should be able to give me whatever form of it that I asked for. Okay, let's move on to problem number 44. This is the beginning of polynomial inequalities. So for polynomial inequalities, like x squared is less than x plus 2, there's a couple things that you're going to have to do. So the first thing that I would suggest you do is get 0 on one side. So let's say get 0 on one side, 0 on one side. So to do that, I'm going to move all these terms over to the left-hand side because I want to keep the x squared term positive. So that's going to be x squared minus x minus 2 is less than 0. Yay, I got 0 on one side. Now I want to find out where this actually equals 0. So set equals 0 and solve. So x squared minus x minus 2 equals 0. Where does that actually equal 0? Or how am I going to solve that? Thank you. X minus 2 and x plus 1. So it equals 0 at what values of x? 2 and negative 1. So that 2 and negative 1, those points divide up your real number line into 3 intervals. Let's see that. So negative 1 and 2. So it divides up your real number line into these intervals, into negative infinity to negative 1, negative 1 to 2, and 2 to infinity. We want to decide which of these intervals actually satisfies our inequality. We want to know which of these intervals has points that make this true, that make this less than 0. Now, here's where our technology comes into play. So let's take out our calculators. You could do this by hand, and that's fine. Let me tell you what we're going to do. We're going to test what happens to points in each of these intervals when I take a point from these intervals and put it in this inequality. Is it going to make it positive or is it going to make it negative? Do I want the positive intervals or do I want the negative intervals? Which one's going to satisfy this? Negative. All right, so hit the y equals key. If there's anything there, then clear it out. So we've got a couple things here. And let's enter in the equation. X, and then hit the squared key, minus x minus 2. So we'll enter in that equation. If you're having trouble, raise your hand. Myself or Mimi will help you out. Mimi, up front here, help out a little bit. Now there's a setting that we're going to make, an adjustment we're going to make to our calculator, and we'll only have to do this once. And it has to deal with our table setups. So hit the second key, then the window key. You want to make sure that your window is set with independent set to ask. Doesn't matter, yeah, independent set to ask, dependent set to auto. So hit the second key, then the window key, cursor down, press enter with window, the independent on ask. With that, then we should be able to get our calculator to give us a t-table in the way that we want. So has everyone got this change?
How do you get that again?
You hit the window key, excuse me, second key, then the window key. Second key, then the window key. Then go down and press ask. And then you should be done. Leave it there for the rest of your life, okay? Don't touch it. Now, hit the second key, then the graph key, and this will give us a table. So this is the t-tables that you use when you set up, when you graphed your linear equations back in beginning algebra, etc. This time what we want to do is we want to test points from each of these intervals. So let's see what happens. Let's pick some points here. What would be a point in this interval from negative infinity to negative 1? Negative 2. How about a point in the interval negative 1 to 2? 0. And from 2 to infinity? 3. I mean, you don't have to choose really crazy points. There's nothing wrong with choosing some simple points. So let's type in these numbers. If you have numbers here that you find confusing, etc., you can hit the delete key right here and get rid of the old numbers. Now we'll type in negative 2, 0, and 3. Now the numbers that I get here don't really matter so much. I got 4, negative 2, and 4. What matters is the sign of those numbers. So the signs that I got out of this went like this. The numbers from this interval, when I plug them into my inequality, make it positive. Here they were negative, here they were positive. So which of these intervals satisfies the inequality? Thank you. Thank you both. The middle one. This is our solution. Right there. So solution is negative 1 to 2. Now I'd probably be a little leery of giving a problem like this because it almost seems as if our answer is just those two. It's not just these two numbers, it's the entire interval. It's every single number between negative 1 and 2. Let's try another one, kind of similar to that one. Problem number 50. X squared is greater than or equal to 9. I like to do a problem like this because it's so tempting to do it wrong. I mean, really, be honest. In your heart of hearts, you just want to say, oh, take the square root on both sides. Done. Cool. Time to go hit the beach. But you can't. There's a little bit more to it than this, than just taking the square root on both sides. So the first step we did on the last one was to get 0 on one side, right? So let me move the 9 to the other side. X squared minus 9 is greater than or equal to 0. What do we do after that? Yeah, we want to find out where this is actually equal to 0. Find out where does x squared minus 9 equal to 0. And that's going to factor, right? What two solutions do we get when we factor this? Good, plus or minus 3. Let's put those solutions on a number line. Because we want to find out overall, where does this thing become positive? Where is it negative? So let's take a look at what happens when I put these numbers on the number line. I divide up my real line into intervals. The first one is negative infinity to negative 3, and negative 3 to 3, and 3 to infinity. I need to test points from each of these in these intervals. So I'm going to test them in this expression right here. The expression that I got when I made one of those sides equal to 0, or one of those sides 0, and then this is the other side of it. So, what would be some good test points here? Negative 4, 0, 1. Let's do 5, just for something different, right? Now, you could go back and plug these in your calculator, but I think this is a simple enough expression we can do it without our calculator, right? If you plug in a negative 4 into x squared minus 9, am I going to get something positive or negative when I simplify this? Positive, right? Get a positive 7. But the important thing is not that I get a 7 in particular, it's that I got something positive. How about the middle interval? If I put in a 0, 0 squared minus 9, well, it's minus 9. But what's the important thing there? Yeah, that I got something negative. Good. So, question? Go ahead. Something, Lucas?
I just consider this
What's that?
a three-plane instead of a two-dimensional line. Everything that falls below the line is negative, and everything above the line is positive.
Part of what we're doing here is kind of setting up a pattern of work that's going to help us out with higher degree polynomials and rational polynomials. So it's kind of setting the stage, is setting the tone for other work we have to come. There is other things that we can do. You can think about the graph of y equals x squared minus 9, and yeah. Now your visual image of that graph helps out for a simple function like that. But what's going to happen when you deal with a polynomial function like x plus 3 squared times x plus 1? Most of us probably wouldn't have a good mental picture of what that graph would look like. So right now what we're doing is we're just trying to learn a little pattern of work.
And again, that's what I was trying to figure out. What are we working in degrees? Is that what that is? Where you start trying to figure out if it's going up and going down?
Yes, that we'll do more of that in chapter 3, I think, is learning how these polynomials look. But right now we just want to determine where they're positive and where they're negative, and help decide. Let's see, that'll be 16. So help decide which of these intervals satisfy the inequality. I guarantee you, there's some calculus students that would love a review in this kind of stuff, because you have to do that in a calculus course to decide where derivatives are positive and negative. So to finish this up, though, we ended up with 2 intervals that were positive and 1 that was negative. Is it going to be the positive intervals or the negative interval that's going to satisfy this inequality here? Positive. So this one and this one are going to be my solutions. There is something that's a little bit different about this one as opposed to the previous one. I've got a greater than or equal to. What's that going to mean in terms of my solution? Yeah, good, they're included. Yeah, there's a couple things. But the most important thing is that the endpoints are included. So negative infinity to negative 3, bracket. And then I like that you use union. Union, 3 to infinity. So there's really 2 different intervals of points that satisfy the inequality. If you put or here, if you forget the union symbol, I'm not going to worry about it. But there are 2 intervals that satisfy that inequality. How are we looking at problem number 50? Because we kind of bumped this one up. Thanks, Anwar. Let's try problem number 52. Now, problem 50, you can visualize what the graph of that would be. 52 is a little bit more challenging. So x minus 5 times x minus 2 times x plus 1 is greater than 0. Well, at least it's friendly in the sense that it's already factored for us, right? In fact, you should be able to So the first step is done. You should be able to read off where this actually equals 0. Alan, maybe you can help me out here, please. All right, a positive 5, positive 2, and negative 1. Now, why don't you see if you can't write down the intervals that these 3 points create? Now, those 3 intervals create a total of, excuse me, those 3 points create a total of 4 intervals. But write down in interval notation what each of those intervals are. Figures. All right, so let's take a look at what our intervals would be here. Alan, what would be this interval to the left of negative 1? Good. And then negative 1 to 2. What's the last one? Perfect. Thank you. So I need some test points in each of these intervals. So let's see.
Are they all going to be round?
Great question. Because this is a greater than, our final answer is going to have all parentheses, no brackets at all. If it was a greater than or equal to, then they'd have brackets, except for infinity and negative infinity always get a parenthesis. If you accidentally put a bracket around infinity, I'm not going to mark you wrong. But just FYI, infinity and negative infinity, we get a bracket or a parenthesis always. I need some test points here. All right, so negative 2. What else? 0, good. Maybe a 3 and a 6. Now before I test these, what do I have to do? If I'm going to test these in my calculator, before I test them, I got to put in that function. I got to put in this thing right here. You don't have to multiply it out. You just write it as is. So hit the y equals key, and let's type in x minus 5, parenthesis, x minus 2, parenthesis, x plus 1. So type it in just like that, and then we can do our test points. So zoom out a little bit. You hit the second key, then the graph key, that takes you to the table function. If you hit delete here a couple times, then boom, we're in good shape. We can do all our test points. Negative 2, where else would we go? 0, 3, and 6. 3 and 6. Are you guys getting the same numbers? Good. What's the important information that I need from here? Yeah, I need to know where it's positive, where it's negative. And it has a reassuring pattern. Often, but not always, often this pattern should alternate. Negative, positive, negative, positive. So let's write that down up here. Negative, positive, negative, positive. Taisha, which ones do I want? Do I want the positive intervals or the negative intervals? Good. I want the positive intervals because I want to know where this is greater than 0. So I want this one and this one. So your answer, when it's all said and done, is just those two intervals. So -1 to 2 union 5 to infinity. Nice. Do you want to do another one like this kind of really quickly? There's problem 54. It's like this, but I mean it has a little bit of a twist to it. All right, no takers on that one. That's fine. Yeah, go ahead, please. Oh, great question. An important question, right? Because if you have the wrong set of intervals, then it's the wrong answer. I want to know where this is positive based on the sign. It's greater than 0. Greater than 0, I want the positive intervals. If it was less than 0, then I'd want the negative intervals. So it's just based on the sign of the inequality once you get 0 on one side. Okay? If you look at problem 54 at home, it's not going to exactly go through this positive, negative, positive pattern. So it's just a heads up. This is reassuring when you see it. If you don't, just look back. Let's look at some rational inequalities. So rational inequalities we're going to deal with much the same way we dealt with polynomial inequalities. So your rational inequalities. Rational ratio. I think by now you understand that that's mathematics speak for fractions. And shamefully, I'm not at the right page because I don't know the problem number of this one. It's 2x plus 6 over x minus 2 less than 0. 60? Thank you. This is similar to what we did with polynomial inequalities, in as much as we need to find a couple places where this is 0, etc. The only difference is that instead of having a polynomial equals 0 and figuring out where each factor equals 0, we have numerators and denominators. So I need to find where the numerator equals 0. For instance, 2x plus 6 equals 0 is 2x equal -6 or x equal -3. Where does the denominator equal 0? 2. So those are my 2 points. Those are what I'm going to use to break up the number line, and I'll be testing in those intervals or in between those intervals. So I got points at -3 and 2. That gives me intervals at -infinity to -3, -3 to 2, and 2 to infinity. Okay, so I need to do some testing of points. This is just the same thing that we did with our polynomial inequalities. You have to start by entering in this expression into your calculator. One little heads up, when you enter that expression, there's a couple ways to do it, but you need to be a little bit careful to enter it with parentheses or do something a little fancier. It's 2x plus 6 in parentheses divided by, again, parentheses, x minus 2. If you forgot the parentheses, then you'd just be dividing 6 by x rather than the whole numerator by the whole denominator. I need some test points. Sure, -4, 0, and 3. Sure, those are good test points. So -4, 0, and 3. I'm guessing we're going to get a positive, negative, positive. Is that it? Yeah. So notice in the first case we got a fraction. That's okay. It's still a positive fraction. 0.33333. What fraction is that anyways? 1/3. So, but it doesn't matter exactly what we got. It just matters that it's positive. Positive, negative, positive. Alan, let me go back to you and see if you pick this up. Do I want the positive interval or do I want positive intervals or the negative interval as the solution? Negative. Good job. So the answer is -3 to 2. Let me give you a little heads up on this problem though. If this was a less than or equal to, typically you get brackets. But there's one point here that I can't use. In fact, let's see that on our calculator. What if you put in a 2 into your calculator? Put in a 2 into your calculator and see what you get. Why is it giving me an error? Right. What's going on when my denominator equals 2? What's happening? It's 0. You're dividing by 0 when your denominator is 2. You can't do that, so you'd have to use a parenthesis around 2 in any case. Now, if I type in a -3, I get 0, which, okay, we calculated where the numerator would equal 0. Putting in a -3 there, yeah, the numerator is 0. If this was a less than or equal to, I could use the -3, but I can't use the 2. So be on guard for that. Yep, there's your answer right here. Thank you. Okay. There's one last type of inequality that we're going to work on, and these are absolute value inequalities. There's two different cases. I'm going to try and get through these kind of quickly, and then we'll wrap this section up and give you a quick break. So there's the less than case and the greater than case. And these are for absolute value inequalities. So let's start with an example. The absolute value of x is less than or equal to 8. Let's look at a number line. What values of x can I put in here that satisfy this? Well, here's 8. So I can put in an 8. 8 is less than or equal to 8. Anything all the way to 0, I'd include, right? But then I can take in the absolute value of, say, -4 is 4, and that's less than 8. In fact, everything between these 2 points, when I take its absolute value, will be less than or equal to 8. But I can't go further than this, right? I can't put in a 9. I can't put in a -9. The absolute value of 9 is not less than 8. The absolute value of -9 is not less than 8. So I'm just stuck with the stuff in between here. But let's see if we can't write this with an inequality. Writing it with an inequality would be -8 is less than or equal to x is less than or equal to 8. So that's saying the same thing here. Let's flip things over here to the other side. The absolute value of x, let's say it's greater than 8. Now, absolute value of x greater than 8 is going to be kind of the opposite situation. I don't want the things in between here anymore, right? I want the things on the other side of 8. So I want everything to the right of 8 and to the left of -8. So when you're solving these types of problems, your solutions for these are going to look a lot different. You're going to have x is less than -8 union x is greater than 8. Those are your two solutions. So in the less than case, you're going to have one big interval. In the greater than case, you're going to have two intervals that face away from each other. So let's do a couple problems like this, kind of on the quick. Starting with problem number 82. The absolute value of 5x minus 2 is less than 8. There's really two ways to solve these types of problems. As an example of the greater than case, problem 84 is the absolute value of 8x plus 3 is greater than 12. It's actually more than a couple ways to solve these types of problems. But let me start with showing you this one for problem number 84. There's two cases. What's inside here could be positive. If what's inside here is positive, I wouldn't need the absolute value. So I just write it without the absolute value. 8x plus 3 is greater than 12. And then solve for x. So that's one possibility. Another possibility is what's inside here could be negative. In which case, to get it out of the absolute value, I'll take its opposite. So I've got a positive case and a negative case. If I solve here, again, I don't think I'm going to get anything really warm and fuzzy in terms of a nice even number, but that's okay. Here's a reminder. What happens when you divide both sides of an inequality by a negative number? Good. The direction of the sign switches, so I end up with something like this. When I divide both sides of an inequality by a negative, the direction of the sign switches. Now let's look at the graph here. It's going to look like this if I did my work right. Two intervals that face away from each other. So I've got negative 15 over 8 and 9 over 8. This first one asked me to give numbers that are bigger than 9/8, so that would be to the right. The second one wants numbers that are smaller than negative 15 over 8. So there's your answer. So there's two possibilities. You could do likewise for problem number 82. Set up a positive case and a negative case. There is a little bit of a shortcut in problem number 82. Now, I typically don't show this to my intermediate algebra classes, but you can if you want. Instead of doing this positive and negative case, do it all kind of as one big long case. And it's inspired from this up here. You have to repeat this. So it'd be negative 8 is less than 5x minus 2 is less than 8. And now we can solve this as one big long inequality. You would add 2 to all sides of this inequality. Have I finished solving for x? Divide by 5. So negative 6 fifths is less than x less than 2. Now, this inequality asked me for everything in between these two numbers, so I'll join it like that. So the absolute value less than case is one interval. The absolute value greater than case is two intervals. Okay, let's call it a day for this section. Let me give you some homework. 17 through 33. 39 through 55, 59 through 65, 75 through 87, and 95 through 101. It may sound like a lot, but I'll give you 2 days to work on it, okay?